So here is target 8, which you hadn't actually seen before. I didn't have it in the configuration because you can't really attack it on a 64-bit system effectively. So why is that? Well, you can't really tell from looking at it here, but take a look here at the stack. It's at 562E601C8000. And we probably just have to remember the 1C8000. That should be enough. Let me just switch temporarily over here to target 6 and then switch back to target 8. Yes. So remember the last time the stack started at 1C8000. Now it's at FB6000. That's because we have something enabled called ASLR. And it randomizes the address space for the program and the stack. And so program, let's see, it's 55D652FB7149. So 55D652FB7. Let's see if that's the same. 55D652. Yes. Back to target 8. Yes. Yeah, so you remember before it was 55B652. The last part, the 149, is still the same because it's essentially relative to the same block, but it's picking a different block each time for the program and for the stack. So think about how that blows the hole in what we did in target 6, because you can't enter you can't put the return address to someplace on the stack if you don't know where the stack is, and every time it runs it's different. And so while you're in a debugger, that's fine, but when you run it outside the debugger, you have no way to tell what the value is. So one way that this has been attacked is that you can create what's called like a no-op sled, where you just, in your input, there's an instruction that means no-op. It means do nothing, and you would just enter no-ops for like thousands and thousands of addresses, and then put the instructions you want to execute, and then essentially take a guess and say, okay, the stack is usually in this range, and pick a number, and hopefully that number will point to somewhere in that no-op sled, and then it'll just keep executing the no-ops until it gets down to the code you want. But this is a 64-bit system, and the no-op sled attack is less effective because the number of possible places the stack can start at is a very big number. It's when I just did a spot test, it was on the variation was around 34 bits, so that's 16 billion, I think, 16 billion possible starting areas. So what are the chances that you're going to pick anything near where the stack could be? So that's problem number one as to why this one is not so easy to attack. Problem number two is that I was careful enough let me bring over a shell here. We're running target 8, and that is process number 1104422. If I look at /proc/1104422/maps, this is the memory map of the program. And one thing you'll see here is that the memory map for stack, the permissions on stack don't have X, which means that the stack is not executable. So again, the exploit that I did on target 6, I can't do on target 8 because you're not allowed to execute code on the stack. And the good thing is that, especially on Linux, and I believe this is true on Windows and the Mac, and it's becoming true on FreeBSD, but I don't think it is the default yet. ASLR and non-executable stack are the default. you can compile your program so that it may not be able to randomize the program, but it can still randomize the stack. To randomize your program, you have to make sure that you haven't turned off position independent code. And you have to do something special to enable stack execution. So I've had to, for the other targets, the ones that especially target 6, I had to turn off stack execution. And when you're running a debugger, GDB, it defaults to turning off the randomization. So I've been using that for all the other targets, turning it off explicitly. Well, it's been that way. I actually had to disable the turning off of randomization for target 8 just so you could see what target 8 would look like in real life. And so the good thing is that these safety checks, the things that make it almost impossible, it's almost impossible for me at least to hack target 8, these things are defaults on Linux, and you don't have to do anything special to enable them. You have to do special work to disable them. And there's a way to turn off ASLR in Linux for all processes, which you probably don't ever want to do. And there are ways to turn stack execution on. There are some programs that use stack execution, but normally you should leave that off. And it thwarts most of the attacks that we've seen, other than the ones where you've hard-coded things that can be disassembled and figured out from disassembly, the XOR, the hard-coded password, and so forth. But that's the final exercise. If you care to try to attack target 8, go right ahead. You can compile it in the source code and just add it to the config for the server. But that is all the targets.